Hi everyone, my name is Hamza and I am a student in Jakarta Intercultural School. I am graduating in 2022 and I've been programming in Go for almost 2 years now. Today I'm going to be talking about the basics of Go and WebSockets. So why WebSockets? Well, before I can answer that question, I need to give a little bit of a basic on HTTP for those who might not know. So in the world of HTTP, we have the browser and the server. The browser requests information from the server, and the server can process that request and then give a response. So when the browser gives a request, it gives contextual information, like what kind of information it needs and information to identify itself. And then the server can process it, and they can either give back the data that they want, or they can even say that I don't have this data, or that you're not authenticated to receive this data. HTTP is a protocol where you have data sent to you upon request. If the server gets new information and wants to send it to the client, it has no way of letting them know unless the client asks for it first. This was fine when the web was originally created a few decades ago, where we had single-page HTML documents where everybody could just load it once and interact. But now in the modern web, this is not ideal anymore, because how would you make things like social feeds, where if you go to Twitter or Instagram, you automatically have comments and likes updating, or make like chatting applications such as Discord or Slack. You can't make collaboration suites like Google Drive or OneDrive. Data streams for like web, like online chatting with a video or just like sensor data is not possible either. And making games run in the browser is just impractical because there's no way to transfer data in real time. So what are WebSockets? One definition I often use to describe WebSockets is a protocol for communication, a real-time communication between the browser and the server. So how do WebSockets work? So in WebSockets, there is no need for data upon request. Instead, what happens is that the browser first initializes a connection with the server. After that happens, both are free to send data back and forth whenever they wish. And there is no time limit, and it can be either the server or the client. No need for a ping pong. So the server can send data foo to the server to the client, and the server can also send data once more, such as bar. So under the hood, WebSockets are similar to HTTP, but have a few differences. Firstly, all of the requests have an upgrade header that let the server know that I want to convert this request into a WebSocket one. They keep the TCP connection that was established by the HTTP alive and use that to communicate data. Instead of using HTTP, you use the WS protocol, and each of the data that is sent back and forth is known as messages. The messages are made up of multiple frames, which can be really good when you're working with larger messages like video data, so that they can be broken down and sent more efficiently. There are a couple of alternatives like server-side events. If the server gets info, though, it has to wait until, so with server-side events, unfortunately, it has only unidirectional data, so only the server can send data to the client. There's no way for the client to send data back to the server. This can also be, there's also another problem where the server does not know if the client disconnects and only finds out when they try to send a request and it fails. HTTP long polling, on the other end, has the functionality for data to be sent both back and forth, but unfortunately, it can be a lot more intensive on the server and take up a lot more bandwidth as well. So now I'm going to go over the basic server-side implementation of WebSockets. For this, we're first going to create a basic HTTP application just to know where we're getting started. So over here, we have the verify endpoint. And whenever that is called, we have this index handler function that will be called. Here, we can see that we just take the writer to the response and write hello world to it. Once we have that set up, we just start up the server and listen for any incoming requests on port 8080. We can test this using a basic curl client, and we can see that when we send a request to 8080 and the endpoint of verify, we get the information back of hello world. Now we're going to talk about how we can handle requests to WebSockets and how we can deal with them as a server. For WebSockets, I actually chose not to use the standard library and instead chose to use Gorilla's WebSocket library. It has many features that the standard library doesn't, and it's also, in my opinion, much easier to interface with, so you have a much better development experience. So here we have the basic setup for accepting incoming connections to a WebSocket client. We can see that we have a basic function setup where every time that we receive a request, we have data of the request, which is in the second parameter, as well as a way to send data back using the response writer. But we also need some extra setup, and WebSocket upgrader. Basically, the role of this is to convert the connection from a regular HTTP request into one that can be used for WebSocket communication. We also can configure a few settings, and those are a little bit more advanced, and I just set the maximum read and write sizes to 1 kilobyte. Next, when we receive a request, we want to first convert that connection into a WebSocket 1. So here we give it both parameters, and we go ahead and upgrade the connection. But this has a possibility to fail. For example, let's say that the client decided to not actually send a WebSocket request and just a basic HTTP request. In that scenario, we can go ahead and let them know that there was a connection error. This can also happen if the client doesn't support WebSockets, and that is just, we just deal with that. Next, we will move on to dealing with the implementation of receiving messages from the client, as well as disconnection. So here we added a for loop as well as a close method that will help clean things up for us. But before we cover that, let's go ahead and remove the stuff that we've already covered. The first thing that we do is we use a defer statement with the close method. Basically, this just lets the HTTP, the WebSocket client know that once we are done with this function, to close the connection for us. The defer makes it so that even if we have a return statement early on, we don't have to explicitly close it, and we just know for sure that it will close regardless. Next, we move on to this for loop. We are not sure how many messages the clients will send or if they will send any at all. So we just have an infinite loop where we keep receiving messages and dealing with them as they come. So we use this ws.readMessage to wait until either the client gives us a message or if there's an error. If we are to receive a message, the first parameter is of the type of the message. Most commonly, it's either a text one or a binary one, but it can also be a ping pong message to make sure that both the client and the server are responding to each other. And it doesn't time out. It's similar to like a heartbeat. Next, we move on to the last parameter, the error. And basically, this will not be nil, meaning that there was some error, most likely when the connection is disconnected from the client. And so basically, when that happens, we have another lifecycle event where we have disconnected from the client, and we can handle that however our application needs to. Next, we convert the message that is initially in bytes over to a string so that it's easier for us to handle. And then we can do our third lifecycle event of handling it however our application needs us to do. So here I have designed a simple echo server. And basically how this works is that whenever we receive a message from the client, we just send it back to them. And so the only thing that's new here is that instead of us handling disconnection and connection in a separate function, we just break out of the code. And whenever we receive a message, we just send it back using ws.writeMessage. Now we can use our basic WebSocket tester to check it out. So here, when we send them hello, the server sends us back hello. And it's the same for when we write 1, 2, 3, and for so on for anything that we send to the server. Now we're going to look at the basics of doing this in the client. And so in the client, there is also 3 lifecycle events. The first one is, but before we do that, we need to first establish the connection. To do that, we just create a new WebSocket type using the DOM API that the JavaScript has available in the browser. We give it the location that we want to connect to, and we let it deal with the rest. The first lifecycle event that we have is onOpen. This is when the server receives our request, acknowledges it, and then finally agrees to open a WebSocket connection if everything went well. Here we can do all of our logic to make sure to start up our chat application that we're going to be doing, or a number of any other things. The next one we have is onMessage. As its name says, it's called every time that the WebSocket server sends us over a message. We can then go ahead and handle it however we wish in this lifecycle event. Finally, we have our close method. This will be called either when the client decides, the client decide to close it, or if the server goes ahead and closes the connection as well. Finally, we have one way to send data back over to the server using the send method available on the WebSocket. Now, I will move on to our basic demo for this chatting application. So the first thing that we're doing is that I just have a basic WebSocket server running in the background. And we can go ahead and see here that we have a little bit of markup to create our chatting application. The first thing that we need is for us to register ourselves. So I can go ahead and type in my name to enter the server. The first thing that we see is that our name was added to the online users. We can type hello, and we get our message saying that we have said hello. If I go ahead and copy this and create a new tab, it will go ahead and allow us to enter another name. I'll go ahead and add Hamza too. And now both of us are connected, and we can see that in our online users. We can go ahead and say, hey, here, and we can see that over in our first one, we get the message saying, hey. Now let's go ahead and take a look at our basic implementation. So here is the basic structure of our application. We have the main.go, where we will be handling creating the WebSocket as well as the HTTP server. We have our hub, which will be mostly handling WebSocket lifecycle events, like when we receive a message, when somebody joins or disconnects. And then we have a static server that will be sharing over our HTML, CSS, and JavaScript files. Let's go ahead and first take a look at our main.go file. So here we can see that if we go ahead and look at our main function, that we have two handlers. The first one handles our /WebSocket endpoint, and this will go ahead and manage our WebSocket connections. The second one that I haven't covered yet is this file server. And basically what it does is that whatever we have in our static directory here, it will go ahead and display it if on the /path. So if I go ahead and click this file, we can see, if we look at our file structure, that we have this verify.txt. If we go ahead and look at its contents, we can see that it contains hello world. If you go ahead and go to our browser, we can make sure that everything is working fine if we go to /verify.txt. And as we can see, that everything is fine, and it shows us hello world. Now, if we go back to our command line, we can go ahead and take a look at how our HTML file is structured. So when we start off, we have our basic head elements, and then we have a snack bar. This snack bar I'll cover more in later, but it's used to handle errors and whatnot. And then we have a modal that we use to enter our username. And then we have our basic chat container, where we have our input to send messages, as well as our online users. Now we can go ahead and take a look at our server implementation. So if we go ahead and go to main.go, we can see here that we have a similar upgrader defined as we saw in our slides. We go ahead and use that to first upgrade the connection over to a WebSocket one. and we let the server know if there was some error in doing. We let the client know if there was some error in doing so. Finally, we add our defer statement so that the server knows that once we've stopped dealing with the WebSockets, that we can go ahead and close the WebSocket connection. Next, we ignore the message type of the server because we handle all of them as plain text. We go ahead and read a message. If there was an error doing so, we assume it to be a disconnection, and we handle it in our WebSocket handler. And we do the same for when we successfully receive a message and want to handle it. If we now go ahead and go over to our hub file, where we can see our WebSocket implementation. So the first thing that we can see is our handle incoming message function. And here, what we first do is, so how our application works is that we have two states for all users. Either the user is registered and is receiving chat messages to communicate with everyone else on the server, or is registering. And when they are in the registering state, the first message that they send to the server will be their username. And so the first thing that we do on line 14 here is we let the server know that if their connection is in this map. In this map, we have a key of value set of the connection ID and all of the information regarding that specific connection, as well as their username. And once they register themselves, they're added to this map. And then we also have a map of the inverse so that we make sure that people don't register with the same username. The first thing that we do is we see if they're already in our map, that means that they're trying to chat with the server. And we go ahead and handle that in our chat message function. Otherwise, we have our little snippet to go ahead and register the user. Now, we have defined a few illegal usernames if it's nothing, or if the username is server, because we use that to let the client know for any lifecycle events. We go ahead and tell them that there was an error if they have an illegal username, and we do the same if their username has already been taken, if it's present in our name to connection map. Finally, we go ahead and send them our list of online users, and then we add them over to our, and we go ahead and register them to the server. Finally, we go ahead and dispatch a server to let all of the clients know that a new user has joined. Now for our disconnection handler. We have two states here as well. If they have disconnected without registering, in which case we just disconnect and do nothing. Or if they are already registered, in which case we go ahead and do a new message. We create a new message and dispatch it to everyone, where we let everyone know that this user has disconnected. And then we also remove them from our maps so that their username becomes free to use for everyone. Our server communicates using 5 different message types. We have the message, where it's like a chat message. We have when people join or leave. We have one where there's an error in some action that the user is trying to do, and when we're trying to send the list of users available. We encode all of our messages in JSON because that's really easy to work with on the client side as well as with Go. And we have all of the information that will always be sent in the similar type of JSON structure. We have the message type, which will be one of the 5 that we've covered, the sender of the message, and if the server is sending it, we use the string server, the content of the information, which can be anything, but when it's a chat message, it's a string. We have the date of the message so that it can be synchronized between people on different time zones. And then we have whether or not it was a successful message or if it was trying to report an error. We have a utility function here called new error, where it quickly creates a structure for us, setting all of the values that we don't really worry about. When we receive a message that wants to be broadcasted, a chat message, we go ahead and use the function send chat message. Over here, we use the message chat type for the message, we go ahead and use their username and the content of the message, and then we go ahead and dispatch. Our dispatch function, which is defined on line 90, goes ahead and goes to all of our registered users and sends them the message. That's mostly it for the server. There's a few things that I didn't cover, and I'll make my code available if you guys want to inspect it more closely. Next, I will go over the basics of how we have implemented the server over on the client side. The first thing that we do is we define all of the elements that we are using, and we store their last used username in local storage just for a little bit better of a user experience. We go ahead and dissect the URL to get our WebSocket connection. So WebSockets also have a secure implementation known as WSS, and we use that if the client is connected to a HTTPS, and otherwise we just use the WebSocket protocol. We go ahead and use the host. So even if we're not working on localhost, you can connect over to our server using HT. You can use it using any domain or URL. Then we go ahead and create our WebSocket connection using the new WebSocket constructor that we covered in our slides. When we go ahead and have our connection open, we then go ahead and show our modal where they can select their username to communicate. When we receive a message from the server, it can be one of the 5 lifecycle events, one of the 5 events that we defined on the server. It can either be a message, a chat message, a join message, a leave message, a user list, or an error. So we first check if it's, we first convert it into JSON so that we can easily read the data through it, and we check if it's an error. If it's some sort of error, we go ahead and show it over in the snack bar. Next, we check if the user is registered or not. If they aren't registered and there wasn't an error, then we can assume that they have now successfully been registered. We go ahead and store their username in our local storage. We hide our modal. We focus the chat, and we know that the first message that we receive when they are added to when they're registered is the current online users. We go ahead and go through all of the ones that are online, and we add them over to our side panel. Otherwise, we know that the message that we received is a chat message sent to us by either ourselves or somebody else on the server. So we have mainly 3 types of messages that we can deal with now, as we've already dealt with the user list one and the error one. And if it's a join one, we go ahead and add them to the side panel as well. And if they're leaving, we do the opposite and get rid of them. Finally, we have our chat message function, where we are able to display it over on our chat. Here, we can see that we have all of the information for creating the chat, the chat elements and adding them over to our panel where all of the messages are available. We go ahead and take the information, and then we form an element and go ahead and append it. And so that's mostly the gist of how this WebSocket server works. And we can see that the 3 main lifecycle events that we deal with are disconnection, connection, and receiving messages. So this project that I created is not very complicated and doesn't go too much into depth. And there's quite a few ways that you guys can extend this if you would like, and do some exercises to make sure that you understand how all of this works. So if you want to take it to a new level, the first thing that you can do is that you can store the messages that the server has received, and whenever a new client joins, you can go ahead and send them to the new clients as well, and so that they can see a little bit of the history. If you want, you can also make it so that you store all of the messages since the beginning of time, so that they can see everything. You can also make it so that people have to authenticate themselves. So perhaps that would mean having a username and a password, and having some sort of database that you connect with. And finally, you can also add support for editing messages and deleting them, which would require you to store information about the messages so that you know that only the right person is able to delete or edit them. And so that's mostly the basics of using WebSockets with Go. And here's a little bit more information about myself and about the project. If you want to see more information and the documentation on our WebSocket client, you can go ahead and find it on GitHub at gorilla/WebSocket. If you want to find more information about WebSockets and with JavaScript, you can go ahead and go to this link to read up more in depth about it. If you want to get in contact with me, you can find me at my email, and the slides and the source code for this demo is available at my website at this link.
This is a question from Muhammad Gifari Yusuf. My company have multi-servers and use WebSocket from live chatting, game, quiz, etc. How to handle if a user send WebSocket and want to send across servers? For now, I am using Redis PubSub. Do you have best practice and suggest for my case?
So for this, I would most likely recommend is that you have one central server, and that central server then receives all of the WebSocket connections, and then you can go ahead and path that over to each of your specific microservice or particular service, and then handle them however you wish. That's if you want to keep only a single WebSocket connection. You can also just have a separate WebSocket connection for each one of your services and have each user connect to them manually. There's no limit on how many parallel WebSocket connections you can have at a single time, but on IE 9, which came out almost a decade ago, it is limited to 6. It's going to be a little bit difficult to give you a particular best practice because it's going to depend a lot on how many clients you have at a single time. But I'd say that the best bet would mostly be for you to have a separate WebSocket for each service and handle them each separately.
All right. So I hope that's clear for Muhammad Gifari Yusuf. Also, let's jump into another question. It's from, let me show you here. It's from Gary Almasamaita. How to perform load tests on WebSocket to measure performance in handling multiple concurrency.
So under the hood, WebSockets all have their own individual coroutines. And so you could probably do some time management to see when a request was made and when the message, when the responses of the messages sent back, if you're doing something like that. But you can also use Go's tools. I think it's called proc tools or something like that, and you can use that to see how the CPU usage is, to see if you need to make your client server implementation more efficient.
How to scale WebSocket with multiple instances?
So honestly, the one disadvantage with WebSockets is scalability. It can be a little bit of a headache as you have to have a real-time communication. And honestly, I could spend another hour just talking about that. I'm free to give you some resources if you go ahead and email me, and I'll get in touch with you on how you can get more particular in scaling WebSockets, because it's not a simple task.
How to perform testing on WebSocket?
So the current library that I'm using, I'm not aware if it has any testing capabilities. But in the past, when I've wanted to write tests with WebSockets, my general goal is to just test the input and the output using a WebSocket client and just do like an integration test. So generally, when I want to do something like this, what I would do is I would have a write pump. There's a great example available in the GitHub repository with, I think it's the Echo example. And over there, what they do is that they have all of the messages that they want to dispatch in a pump, and they just send them over in their own coroutines, and that helps make sure that like if there's some slowdown with the client, it stays smooth for everyone else.
Do you use stickers send it on specific interval?
That is possible, but if you would like, you can also just send it as you get. And if you have a lot of data that is sent or like in packages, using a ticker is, in my opinion, a fair solution.
Do you have tips in handling auto downscale of WebSocket servers to ensure that currently connected users won't be disconnected abruptly?
In those scenarios, I haven't had any personal experience with downscaling WebSockets, so I can't speak from particular experience. But what I would think is what you should do is you should have your WebSocket client be in such a way so that disconnection handling disconnections is possible, because you have to remember that even if your client like sleeps their laptop or anything, the connection is automatically closed, and you have to reconnect anyways. So building on the last question that Roland asked, I would like to mention that when you're working with WebSockets, there is no automatic reconnection, and that you should implement that yourself. And I think that that's a good thing, because you can be more explicit with how you want your reconnection to work and mesh with your application. And yeah, so one last thing is that I would really recommend you guys that when you're working with WebSockets, to keep both sides stateless, and to just reconnect it via communication. Because with WebSockets, it's easy for the client to get disconnected, whether by just closing their device. And so having to have a lot of contextual information that the server expects or the client expects can make your WebSocket implementation a bit more confusing.